So you'll recall there are some special angles when we measure in degree. In fact, the 30 degrees, 45 degrees, 60 degrees, some of those special angles, 90 degrees, some of those special angles that come about. And using those angles as, for example, reference angles, a 30-degree reference angle, we can put that in any of the other three quadrants and create three other special angles. So, to take that example, a 30-degree reference angle in quadrant 1, that's a 30-degree angle. A 30-degree reference angle in quadrant 2, that's a 150-degree angle. A 30-degree reference angle in quadrant 3, that's a 210-degree angle. And then a 30-degree reference angle in quadrant 4, that's a 330-degree angle. So those are all those special angles using those particular special angles, 30 degrees, 45 degrees, and 60 degrees in all the other quadrants. Well, it turns out that those special angles also have some special representations in degrees. And we can find them this way. We're going to start with the base that we start all the time with. Pi is equal to 180 degrees. Divide both sides by 2. Divide both sides by 2. So if I divide both sides by 2, this gives me pi over 2 radians is equal to, divide this by 2, 180 over 2, that's 90 degrees. So pi over 2 is 90 degrees. So let's get our angles here. 90 degrees, 90. This is pi over 2. That angle, that right angle, pi over 2. Now, from that, we can create others. Here's a nice way to think of it. To this day, this is how I count it. I still count it this way. From 0 to vertical, from horizontal x-axis to vertical y-axis, here to here, that's pi over 2. This is 1/2 pi. And then from here to here, that's 1, 2. This is 2/2 pi. 2/2 is 1. This is 1/2, 2/2, 3/2. This is 3 pi over 2. 1/2, 2/2, 3/2. 4/2. 4/2 is 2 pi. So 2 pi radians is coterminal with 0 radians. Those two angles are coterminal. They're not the same thing. A 0 radian angle is this. That's a 0 radian angle. A 2 pi radian angle is one complete revolution. So they are coterminal, but they're not the same angle. Anyway, 1/2, 2/2, 3/2, 4/2. Pi over 2, pi. 3 pi over 2, 2 pi. So all that from simply dividing both sides by 2. All right? Now, let's divide both sides by 3. Pi over 3 corresponds to 180 degrees over 3, which is 60 degrees. And so from this point forward, a 60-degree angle, don't think of as 60 degrees. This is pi over 3. Pi over 3. Or another way to think of it, again, another way to think of it, because now we can take this and place it into the other quadrants as a reference angle. The way I think of it is this. If I take this pi over 3 and place it as a reference angle here, that means this angle is pi over 3. This angle, this reference angle is pi over 3. The question is, how big is this angle? Well, if this is, we know that this is pi. That's 3/3. 1 pi is 3/3. So again, what I do, and I think this is a nice way to think about it, rather than need to memorize a bunch of stuff, just count. This is 1/3, 2/3, 3/3. See my 3/3? And then down here, there's 4/3. And then down here, there's 5/3. 1/3, 2/3, 3/3, 4/3, 5/3, and then if you want, there's my 6/3. 1/3, 2/3, 3/3, 4/3, 5/3, 6/3. Just count by thirds, just like we counted by halves. 1/2, 2/2, 3/2. All right? So divide by 2, divide by 3. I think we know what's coming next. What happens if you divide both sides of this original expression by 4? Well, that's 180 degrees divided by 4, which is 45 degrees. And so we have that angle. Again, don't think of it as 45 degrees. Think of it as pi over 4 radians. Pi over 4 radians. And now, again, I just count by fourths because this can go into any of the other quadrants. But remember, this is 1/4. The next would be 2, but where's 2/4? 1/4, yes, there's 2/4. Do you see my 2/4? 2/4 is a half. And then 3/4. 1/4, 2/4, 3/4. What's next? That's 4/4, 5/4, 5/4, 6/4. Of course, there's my 6/4. 7/4. And then 8/4 there's my 8/4. And so what we see, and this is the way, to me, this is the natural way to remember. No, number one, you could just count them up. In fact, in my mind, I do that almost all the time. I just count them up. Okay, so that's 3/4. That's 7/4. I just remember them. But another way to do this, these, look at them. These are the odd 1/4, 3/4, 5/4, 7/4. I had a professor named Professor Norman, and he was always talking about heartburn. He said, if you learn this, that'll save you a lot of heartburn. If you learn it right now, odd, 1/4, 3/4, 5/4, 7/4. Now you'll have it. Because if someone asks, what happens if you have a pi over 4 reference angle in quadrant 3? 1/4, 3/4, that's 5/4. It's the odd fourths, 1, 3, 5, 7 in the various quadrants. In quadrant 1, 1/4. In quadrant 2, 3/4. In quadrant 3, 5/4. In quadrant 4, 7/4. 1, 3, 5, 7. They're the odd pi over 4s. All right? Next. Well, let's see. I think we know what's coming down the road next. We've divided by 2. We divided by 3. We divided by 4. We could divide by 5. (180 degrees over 5). Turns out that's 72 degrees, and it turns out that is not one of the special angles, so we're going to ignore it. Could, if you wanted to, you could do a 72-degree angle and develop a wonderful geometry or wonderful trigonometry based upon 72 degrees, but that's not what we're going to do from here on out. We'll essentially just ignore that one. Pi over 5 doesn't come into play very often. If it does, then you'll handle it as a special case when you get there. 180 divided by 5 is 72, and if you want to use that, that's wonderful. But we will do almost nothing with pi over 5. Next one in line is a big one, because that's 30 degrees. And so pi over 6, this takes a little getting used to. There's pi over 6 in quadrant 1. Now, when you take pi over 6 and put it in the other quadrants as a reference angle, I think the simplest thing to do is just bite the bullet, just, hang in there, do the arithmetic. All right? So if this is pi over 6, then how much is this? Well, it's pi but you subtract off one of the pi over 6's because we want this angle, right? We want that angle. We want pi, but take away pi over 6. That would be, do you see my 6/6? 6/6, take away 1/6. What's 6/6 minus 1/6 is 5/6. So in quadrant 2, this angle is 5 pi over 6. Pi over 6, and then 6/6 minus 1/6 is 5/6. All right? So let's kind of clean the picture up a little bit. In quadrant 1, this is pi over 6. If I have a pi over 6 reference angle in quadrant 2, pi over 6 reference angle in quadrant 2, then this is 5 pi over 6 because it's 6/6, subtract off 1/6, 6/6 minus 1/6 is 5/6. Now what if we put it in quadrant 3? Well, this is now 6/6 plus an additional 1/6. 6/6 plus 1/6 is 7 pi over 6. And then the last one to concern, what if we're in quadrant 4? What if this is a pi over 6 reference angle? The question is, how big is this angle? And the way we're going to write that is you take, now think of this, if this were degrees, you would go the entire 360, but subtract off 30 degrees. What we're going to do is we're going to go the entire 2 pi, but subtract off 1/6. But we need 6ths. This isn't 2 pi, it's 12/6. 12/6, take away 1/6. 12/6, take away 1/6 is 11 pi over 6. And so what we do is we generate what are called families. There are families, there are reference angle families. Now there's individual differences in each of them, but each item in the family has something in common. This is the pi over 6 reference angle family. Pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. That's the pi over 6 reference angle family. There are some things that there's nothing for it. It just needs to go in your brain. You just need to learn it. You just need to memorize it. Flashcards, whatever it takes. This is one of those things, there's nothing for it. This just needs to get learned. The pi over 6 reference angle family is pi over 6, 5 pi over 6, 7 pi over 6, 11 pi over 6. That's the reference angle family for pi over 6. What that means is, if you're in quadrant 3 and the reference angle is pi over 6, then the entire angle is 7 pi over 6, and so on with the others. And then similarly, we have the pi over 4. The pi over 4 reference angle family. But these are a lot easier. This is pi over 4 reference angle family. And these are much easier. There's a nice little memory device here. It's not just memorized, because these are the odd multiples of 1/4. This is 1/4, 3/4, 5/4, 7/4. So the pi over 4s are much easier because it's the odd pi over 4s. 1/4, 3/4, 5/4, 7/4. If you are in quadrant 4 and the reference angle is pi over 4, if this reference angle is pi over 4, then this entire angle is 7 pi over 4. All right? That's the reference angle family for pi over 4, and there's nothing for it. You just need to know it. The nice thing about the pi over 4 is there's a nice little memory device to help you. With the pi over 6s, there's not much of a memory device. You just kind of need to get in there and grind it out and learn them. Pi over 4, there's a pretty good memory device. And pi over 3 isn't too bad because you can sort of count them. All right? So there's pi over 3 in quadrant 1. If we have a pi over 3 reference angle in quadrant 2, the question is how much is this? Well, again, I just count them. 1/3, 2/3. Let's get rid of this for us here. 1/3, this is 2/3. 3/3 would be a straight angle. So we're going to skip 3/3. And then here, this is 1/3, 2/3. We're going to skip 3/3. 4/3. And then in quadrant 4, we're left with 1/3, 2/3, 3/3, 4/3. This would be 5/3. So if that helps you remember, that's wonderful. But the point is not what helps you remember it. The point is that you remember it. You must know the reference angle families for the radians just automatically. They just need to be part of your mental furniture. And so if we have a reference angle in quadrant 3, if we're in quadrant 3 and the reference angle is pi over 4, then you need to know that is 1, 3, 5. That's 5 pi over 4. If we have a reference angle in quadrant 2 and the reference angle is pi over 6, then you need to know that is 5 pi over 6. That needs to be part of what you know. And you need to do what you need to do so that you learn that. There's nothing for it. You must know it. So flashcards, quizzes with your friends, however you want to learn it, that's fine, but it needs to get learned. And so that's going to become part of you. And learning these special reference angle families for these special reference angles, that's indispensable to almost all the work we're going to be doing going forward in our trigonometry study.